All right, so let's look at some vocabulary for graph theory. So the degree of a vertex is the number of edges at that vertex, and it's found by counting the number of line segments or curves attached to that vertex. Now, a vertex with an even number of edges has its uh, name as an even vertex. For example, in the figure over here, what we can do is we can count these. So like for A, we have one, two, three, four, five edges coming in here. So the degree is five. For B, we have one, two, three. So the degree is three. Here we have one, two, the degree is two. Here we have one, two, degree is two. Here we have one, two, three, four. So it's going to be even number because there's four of them, and so it's going to be that way. Now notice the loop contributes two to your degree because you have one coming in and one leaving. So you have two for that loop there. Okay. All right. So to the right, we have which ones are even? Well, we have a degree of four is even here. We have a degree of two of even, and here's a degree of two, and it's even. Now the odd ones are three and five. So we have even vertexes and our vertices and odd vertices. So A and B are the odd, E, D, and C are going to be the even vertices. Now, two vertices in a graph are said to be adjacent vertices if there's at least one edge connecting them. It's helpful to think of this basically as they're connected vertices. So, if we look at that, DB and DA, those are adjacent edges. That would be kind of how to think about that. So that's what we're going to be looking at here in the next little bit. And what we're going to do is we want to list the pairs of adjacent vertices for the graph in the figure below. And so what I'm going to do is I'm going to say, let's start with our A. So we're going to start there and we're going to list all the things leaving from A. So we'll have A to B, and we'll put a comma between them. And so that one gives this edge. Then we have A to D, so we can have that one. We have A to C, that would give us one. And we also have A to E. So those would be all adjacent. Now, we've taken up all the A's, so now let's go over to B. So now we're going to start next with B. Well, we're not going to repeat B to A because we've already got that one here, but we can go B to C. So then we'll have another one. And so that's all we have here. Now let's just go down from there. Well, D is taken care of. We don't have to worry about it. C, we go over here. It's taken care of, so we don't have to worry about it. The only one left now is E. And what we have left is this loop. And how we represent that is we do E, comma, E. Okay. And so those are going to be all the different pairs of adjacent vertices for the graph here. So we have, in this case, 1, 2, 3, 4, 5, 6 different adjacent vertices for that graph given. All right, so next is a path. So a path in a graph is a sequence of adjacent vertices and the edges connecting them. Although a vertex can appear in the graph more than once, an edge can be part of a path only one time. So you can have a vertex be multiple times, but an edge can only be part of a path once. Now, a path does not have to include every vertex also. That's another key piece here. It doesn't have to include every vertex. So an example of a path from A to E, so down here, we're going to start at A and we want to end at E, is we're going to go from A to B, then B to D, and then D to E. Okay. Now, so we would label that as A, comma B, comma D, comma E. Now, is that the only one? No. We could also done A to B and then B to E, and that would have been one. Or we could have A to B, B to D, D to F, and then F to E. So there's multiple paths we could have done. But remember, the key is you can have an edge only part of the path one time. So you couldn't do, B to D and then D to F and then to G and then back to F. That wouldn't work. So that's why we'd have to come D to F and then F to E if we're going to do this as a path. Okay. So that's how paths work. Now let's stop here and we'll come back for more.